In comparison to old technology aircraft, the flight deck on the A320 is designed to be a comfortable, uncluttered environment in which to work. By utilizing modern electronic display units, the presentation of information to the pilots has been improved. The Electronic Instrument System, EIS, consists of 6 identical full-color cathode ray tube display units. The EIS is divided into 2 subsystems. The Electronic Flight Instrument System, EFIS, for which each pilot has 2 displays. The Electronic Centralized Aircraft Monitoring System, ECAM, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the EFIS system first. The 4 EFIS displays provide the pilots with flight data to help them operate the aircraft in a safe and efficient way. Flight parameters are displayed on primary flight displays, PFDs, while navigation data is displayed on navigation displays, NDs. Each pilot has an EFIS control panel to select what is displayed on the EFIS screens. The EFIS control panels are divided into 2 sections, one section associated with the PFD and the other with the ND. Outboard of the PFD, there are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off. A switch is provided to allow the information on the PFD and ND displays to be transferred. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System, ECAM. The upper ECAM display is known as the Engine Warning Display, E/WD. The lower ECAM display is known as the System Display, SD. It is on this screen that various aircraft system parameters can be viewed by the pilots. As an example, we will cycle through the system pages for you. The presentation of system information is based on a need-to-know philosophy. This means that only the system information relevant to the particular phase of flight is presented to the pilots. You will see this demonstrated in the normal and abnormal operation modules. Another philosophy that is used on the flight deck is the lights-out principle. What this means is that when the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. Let's look at some switches and show the different possibilities. For the majority of the switches on the overhead panel, the push-button switch logic is normal operation configuration, no light showing, the lights-out philosophy. Abnormal condition, amber fault light. This assists identification of the switch associated with an abnormal condition. Non-lights-out switch position, white light. If normally the system should be operating and is deactivated, a white off light is illuminated. If normally the system should not be operating and is activated, a white on light is illuminated. There are some switches on the overhead panel which are used on a temporary basis or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light such as anti-ice. Applicable system status, green light such as APU available. Below the ECAM displays on the center pedestal is the ECAM control panel. The two controls on the left-hand side are to adjust the brightness of the two ECAM screens or to turn them off. We will look at the rest of the controls on this panel in more detail later. Just below the ECAM screens on the pedestal is a switching panel for use in abnormal situations to restore data to the EFIS and ECAM displays. In front of each pilot, there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note, the loudspeakers can also be used to listen to ATC and the intercom. Now, let's go back to the EFIS system. For the EFIS displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management and Guidance System, FMGS, is fed directly to three Display Management Computers, DMCs. The three identical DMCs process the data and generate the images to be displayed. Under normal circumstances, DMC-1 supplies EFIS information to the captain's PFD and ND. DMC-2 supplies the first officer's PFD and ND. DMC-3 is available as a backup. Now let's look at the other EIS subsystem, ECAM, and how the ECAM displays get their data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated on the flight deck. Data for certain parameters, for example, fuel quantity and primary engine indications, is routed directly from the system sensors to the three DMCs. Note that there are separate channels within each DMC for ECAM and EFIS. For a majority of the systems, the sensors supply data to two Systems Data Acquisition Concentrators, SDACs. The SDACs acquire system data, process it, and send system page data to the three DMCs. Normally, DMC-1 supplies the engine warning display. DMC-2 supplies the SD, the system display. Two identical flight warning computers, FWCs, receive data from the aircraft system sensors to generate red warnings, the SDAC to generate amber cautions. The FWCs then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts, and synthetic voice messages.
Speed, speed, speed.
All the components shown can be collectively called the ECAM system. We will study the use of the ECAM system in a separate module. The master time reference for all aircraft systems is provided by a clock located on the right lower side of the main panel. The time is also displayed at the bottom of the system display. The two chrono push buttons, located on the glare shield, control the associated display on the individual NDs. The chronos operate as stopwatches, measuring either seconds, minutes, or hours. The ECAM system monitors all aircraft systems and alerts the crew to any abnormalities. If something abnormal is detected, ECAM will alert the pilots and provide an electronic checklist to help handle the abnormality. The two ECAM displays, the EWD and the SD, are where the ECAM system provides normal and abnormal system information to the pilots. Color coding is used on the ECAM screens for clarity and to aid identification of abnormal parameters. The main colors used are white, blue, green, amber, red. During the course, you will become familiar with the use of this color coding. Let's start with the last three, green, amber, and red, which are the most important. Green is used to indicate a normal condition. Notice that on the engine warning display and the system display shown, all indications are normal. Amber is reserved for abnormal indications that require crew awareness but not immediate crew action. Notice on the EWD the amber failure message and on the SD the amber indications. Red is reserved for serious parameter exceedance and warnings that require immediate crew action. Notice on the EWD the red parameter indication and the red warning message. Let's now look at the two ECAM displays in a little more detail. The EWD is divided into two main parts. The upper area is used for the main engine parameters, fuel on board and slat flap position. Under normal conditions, the lower part of the EWD is used to display memo. In the example shown, the memos indicate that the seat belt and no smoking signs are switched on and that the APU is available for use. If failures occur, warning caution messages are displayed in place of the memos. In the example shown, there is an amber caution message with a series of blue action items. These action items are your electronic checklist to respond to the particular abnormal situation. The SD is used to display particular system information. In the example shown, the cruise page is displayed. This is the page normally seen for the majority of the time that the aircraft is airborne. Information that is useful during flight from several systems is displayed. The individual indications will be covered in the appropriate system modules. The SD can also be used to display synoptic diagrams of the aircraft systems, system pages. In the example shown, the hydraulic system page has been called. You will see later how these system pages are called either manually or automatically. An aircraft status page may be displayed on the SD to check the state of the aircraft. A normal message is displayed to indicate that the aircraft's state is normal and that there are no inoperative systems. Let's see what the status page looks like when things are not normal, for example, following a system failure. The information displayed on the status page will vary depending on the failure, but as an example can include limitations, approach procedures, including actions and corrections, information, inoperative systems. The area at the bottom of any SD contains permanent data: total air temperature, TAT, static air temperature, SAT, time, gross weight. Under normal conditions, the ECAM system provides the pilots with the information that they need to know for the particular phase of flight, no more, no less. As an example, during the approach when the landing gear is extended, the ECAM wheel system page is automatically displayed. The ECAM system divides the various stages of a flight into phases, from initial electrical power-up until after the engine shutdown. The ECAM system will avoid alerting the pilots unnecessarily during the critical flight phases of takeoff and landing. The warnings and cautions that can be delayed until a less critical phase of flight will be inhibited. We will now look at the different ways that the ECAM system advises you when things are not going exactly right. We will start with the minor advice indication and work up to a major fault, concentrating on the two ECAM screens. If a system parameter, for example an engine vibration level, approaches a limit, the ECAM system will advise you of this by displaying the relevant system page on the SD. The affected parameter will pulse. Notice that at this stage, the parameter is still shown in green since it is still within normal limits. This is known as an ECAM advisory. Now let's look at what happens when ECAM detects a minor system failure. When a failure occurs leading to a loss of redundancy or loss of a system that does not affect the safety of the flight, for example, digital flight data recorder fault, the ECAM system will inform you by displaying an amber caution message on the EWD. At the same time, the two clear keys on the ECAM control panel will illuminate. The first action is to ensure that the aircraft is on a safe flight path. This fault only requires crew awareness, so if required, the handling of the fault can be delayed. Normally, the pilot not flying carries out the ECAM procedure, while the pilot flying is responsible for the aircraft's flight path. For this exercise, you are the pilot not flying. Read the title of the failure, in this case, Recorder DFDR Fault. The pilot flying will ask you to perform ECAM actions. UAL SOP. The captain will determine who flies and who does ECAM. In this case, there are no actions required, so after confirmation from the pilot flying, the caution message can be cleared by pressing one of the clear keys on the ECAM control panel. Press a clear key. As a result of pressing either clear key, the caution message has been cleared from the EWD, and the status page is displayed automatically. In this example, you can see that the inoperative system is the DFDR, Digital Flight Data Recorder. On the ECAM control panel, the status key is illuminated, along with the two clear keys. When safe to do so, the status page is reviewed by both pilots. After confirmation from the pilot flying, the status page is cleared by pressing either the status key or one of the clear keys. Clear the status page. Notice that on the EWD there is a boxed STS caption to tell you that there is information on the status page. On the ECAM control panel there are no lights. The ECAM actions for the DFDR fault are complete. The UAL standard response is ECAM complete, screens normal. We will now look at what happens when a slightly more serious fault is detected by ECAM. The fault that we will use is an overheat of the blue hydraulic system reservoir. We will concentrate on the use of the ECAM system, how it alerts you, and how it helps you to deal with the fault. The hydraulic indications themselves will be covered in the appropriate modules. When the fault occurs, the ECAM system alerts the crew orally and visually. You will hear a single chime and see the master caution lights. To cancel the master caution lights and reset the alerting system, one of the master caution push buttons must be pressed. Extinguish the master caution light. The master caution is extinguished and the alerting system is reset. The first priority is always to ensure the safe flight path of the aircraft before dealing with the fault. The master caution means that the abnormal situation needs crew awareness, but not immediate action. The indications are a failure message on the engine warning display. The system synoptic associated with the fault is automatically displayed on the system display. The clear keys on the ECAM control panel light up. Let's study the details on the EWD first. The system title is underlined, in this case hydraulics, and the fault is shown alongside, blue reservoir overheat. Notice that abbreviations are used. If you look carefully at the hydraulic system display, you will notice an amber overheat message. This abnormal indication is how the fault is shown on the system synoptic. The pilot flying will ask you to perform the ECAM actions. In this example, there is a blue action line on the engine warning display telling you to switch off the blue electrical pump. Let's check the overhead panel. On the overhead panel, an amber fault light has illuminated on the hydraulic control panel. The fault light on the hydraulic panel helps you to locate the switch to be operated. We will carry out the action for you. When the pump is switched off, the action line is removed. The blue hydraulic system depressurizes, as shown on the hydraulic page by the amber indications. The ECAM system detects the drop in pressure and generates a further alert. You hear the chime and see the master caution lights. Extinguish the master caution lights. There is now a new abnormal message on the engine warning display, blue system low pressure. The message is boxed to indicate that the loss of the blue hydraulic system is classed as a primary failure that will affect other systems. The systems affected are shown on the right of the EWD as starred items called secondary failures. In this example, the primary failure of the blue hydraulic system has caused a secondary failure of flight controls. After review and confirmation from the pilot flying, the hydraulic failure message on the EWD can be cleared. Clear the hydraulics message. Notice that normal memos have returned on the left side of the EWD. The ECAM Flight Control System page is displayed on the system display, which corresponds to the secondary failure item on the engine warning display. On the ECAM Flight Control page, notice that the controls affected by the loss of blue hydraulics have amber indications. These indications will be discussed in the hydraulic and flight control modules. After review and confirmation from the pilot flying, the flight control secondary failure message can be cleared. Clear flight control. Notice that the secondary failure indication on the EWD is removed. The status page is now displayed, containing several pieces of information. The first area gives procedures to be applied for approach, landing distance factors, and other information. In this example, the inoperative systems are Cat 3, which means that Category 3 Autoland is not available. Blue hydraulic, the system was switched off during the ECAM procedure. Spoiler 3, the spoilers that are inoperative because there is no blue hydraulic pressure. The status page is reviewed by both pilots. After confirmation from the pilot flying, the status page can be cleared. Clear the status page. The ECAM actions for a blue hydraulic reservoir overheat are complete. Notice that the status reminder is displayed at the bottom of the EWD, reminding you that there is information on the status page. This is important since there were approach procedures to be applied. If it contains information, the ECAM system automatically recalls the status page during the approach phase when the slats are extended. This is done so that if there are any items affecting the approach and landing, they will be presented to you at an early stage. You can see that in the example shown, there are approach procedures. You will see how these approach procedures are applied later in the course. Clear the status page. The status page is cleared and the cruise page is displayed. ECAM complete screens normal. So far we have looked at how the ECAM system advises you of minor failures. We will now look at what happens when there is a serious failure that requires immediate action. To demonstrate this, we will use an engine fire. As before, we will not concentrate on the system failure, but on ECAM indications and procedures. When the fault occurs, the ECAM system alerts the crew orally and visually. You hear a continuous repetitive chime and see the master warning lights flashing. Pressing one of the master warning push buttons will cancel the master warning lights, stop the chimes, and reset the alerting system. On the EWD, the red message Engine 1 Fire and the associated procedure are displayed. The red indications on the fire panel and the engine panel provide confirmation and identification of the affected engine. The engine page has automatically been called on the SD, and in this example, the nacelle temperature is pulsing. Notice that there is a red Land ASAP message on the EWD. This means that ECAM has determined that the fault detected is serious enough to require a landing as soon as possible. The pilot flying maintains control of the aircraft and asks you to perform ECAM actions. We will do the ECAM actions for you, starting with moving the number 1 thrust lever to idle. The next line on the ECAM procedure is now carried out. We will switch Engine 1 off for you. Cancel the master caution light. After switching Engine 1 off, the after Engine 1 shutdown procedure is shown on the engine warning display. Notice that the amber caution message has appeared below the red warning. This happens because you have to finish the engine fire procedure before carrying out the actions for Engine 1 shutdown. The ECAM system has automatically allocated priority to the warning. As a result of shutting down the engine, there are now secondary failures. The next ECAM action is to push the Engine 1 fire push button. We will do this for you. Notice that there is a white line in the abnormal checklist. In this example, there is a delay in discharging the agent to let the engine spool down. We have paused the countdown at 10 seconds. To continue the countdown, click on the forward arrow. When the countdown is complete, a blue action line appears telling you to discharge the first fire bottle. We will do this for you. The next action line is to notify ATC. Since ECAM cannot tell you if a radio is being used, there is no feedback, and therefore this line will not disappear. Notice that we still have a red fire indication, which means that the fire is not extinguished. Another condition line has appeared, and a second countdown automatically starts. This one is 30 seconds long. Agent 1 managed to extinguish the fire. The countdown for Agent 2 stopped immediately. Notice that the engine fire procedure on the ECAM disappeared. This means the fire is out. The local warnings on the fire panel and the engine panel are no longer illuminated, confirming that the fire is out. Land ASAP has changed from red to amber, which means that ECAM has determined that the fault is less critical, but still requires a landing as soon as possible. The remaining steps are similar to those seen for an ECAM caution, so we will stop here. You have seen that the ECAM system has provided a smart and interactive checklist to help you deal with a major problem. So far, the messages and procedures displayed on the EWD have not been more than 7 lines, so we have had room to display them all. Let's look at how ECAM copes with a long procedure. In this example of the indications for an engine fire on the ground, there is an overflow arrow to indicate that there is more information to be seen. For training purposes, we have shown the rest of the procedure below the EWD. We will complete the ECAM actions, and you will see the associated line of the procedure disappear. As actions are completed, the rest of the information will be displayed and the overflow arrow will be removed. On the status page, an overflow arrow also indicates that there is further information to be seen on the second page. By pressing a clear key, the next page can be displayed. Press a clear key. The second page of status information is displayed. Notice that the list of inoperative systems has not changed and that there is still an overflow arrow. Again, press a clear key. The last page of inoperative systems is displayed and the overflow arrow is removed. If you want to display the first status page again, the status key can be pressed. Press the status key. We are now back at the first status page. To summarize, initially you see all the information on the left side of the status page and all the inoperative systems on the right. To complete this module, let's briefly look at ECAM priority. We will only use the bottom part of the engine warning display for this information. You are partway through the Engine 1 fire procedure when ECAM detects another failure. The low priority recorder DFDR fault has appeared below the higher priority engine 1 fire and engine 1 shutdown procedures. Unfortunately, it is one of those days, and another failure occurs. The autopilot off warning has appeared above the engine 1 fire procedure. ECAM has automatically assigned priority to the autopilot off message because the first priority is always to fly the aircraft. The low priority recorder DFDR fault is now off the screen. You are advised that the fault is there by the unstarred recorder text in the right-hand column of the EWD and the green overflow arrow. We will clear the autopilot off warning for you. The recorder DFDR fault message is back at the bottom of the engine warning display, and the recorder text has been removed from the right-hand column. When you initially enter the cockpit, all the EIS displays are normally off. The displays require AC electrical power to operate, so unless either the APU or a ground electrical supply are available, the displays will not operate. We will connect a ground electrical supply for you. Normally, the ECAM screens are switched on in the order of upper, then lower. For training purposes, let's switch them on in reverse order to see what happens. Switch on the lower ECAM display. Notice that EWD information is displayed on the lower ECAM screen. This occurs because it has priority. Therefore, if there is only one ECAM screen available, the engine warning display information will be displayed. Now, switch on the upper ECAM display to see what happens. Notice that the engine warning display information moves to its normal position on the upper ECAM screen, and the door oxy system page is displayed on the lower ECAM screen. The door oxy page is what the ECAM system will automatically display because you are on the ground with the doors open. The memo area of the engine warning display has a message telling you that refueling is taking place. We will now start the APU. When the APU master switch is pushed on, the APU ECAM page automatically appears. Next, the start switch is pushed, and the APU begins its automatic start cycle. Note that there is no light on the ECAM control panel APU push button because the APU page has been automatically called as part of a normal sequence. The APU is now running as evidenced by the avail light on the APU start push button. Shortly after the APU start is complete, the ECAM door oxy page is automatically recalled. During the pre-flight, one of the things we do is check fluid levels. For example, the quantity levels for hydraulic fluid and engine oil. The required system pages are manually called by pressing the associated key on the ECAM control panel. Let's call the ECAM hydraulic system page. The ECAM hydraulic system page is displayed. Notice that there is a light on the hydraulic key on the ECAM control panel to indicate that it was manually selected. You will do the fluid level check in the hydraulic module, so let's see how to return to the ECAM door oxy page. To deselect a manually selected ECAM page, the lighted key on the ECAM control panel is pressed. Press the hydraulics key on the ECAM control panel. The ECAM door oxy page is displayed, and there are no lights on the ECAM control panel. Remember the lights out philosophy. The next action is to press the recall push button on the ECAM control panel for at least 3 seconds. Pressing this push button recalls any warnings or cautions that have been cleared since the last power-up. Since we are starting the aircraft from cold, a normal memo will be seen on the engine warning display because there is nothing to recall. If we were on a turnaround, the display would recall any warnings or cautions that had occurred on the previous flight. In this example, a canceled caution concerning the digital flight data recorder has been recalled. You will see how a caution is canceled in the Abnormal Operation module. At this point, the passengers have boarded, the doors have been closed, and the slides armed. On the ECAM Door Oxy page, observe that there are no amber indications and that there are 6 white slide indications. When the ground personnel attach a tow bar to the aircraft, they disconnect part of the nose wheel steering system. The ECAM system will detect this and provide a green memo indication, nose wheel steering disconnect. Let's start the engines. The ECAM system will automatically display the ECAM engine page while the engines are being started. Notice that as soon as the first engine is running, the nose wheel steering disconnect memo changes to amber. This happens because ECAM has detected that you are capable of taxiing, but you have the steering disconnected. When we arm the ground spoilers, a white band appears on the spoiler handle, and a memo appears on the EWD showing that the ground spoilers have been armed. Also note that the flap indicator has changed to show the takeoff flap setting. Another part of the after-start check involves checking the status page. Since there is no status reminder at the bottom of the EWD, the status page obviously is clear. Approximately 2 minutes after the second engine has been started, a takeoff memo appears on the EWD. The takeoff memo lists a series of actions to be performed before takeoff. In this example, there are blue action items remaining, specifically setting the auto brake to max and the takeoff configuration test. We will set the auto brakes to max for you. The blue action item has changed to green. Auto brakes have been armed to max. The final item requires testing the takeoff configuration. This is done by pressing the takeoff configuration key on the ECAM control panel. Select the takeoff configuration key. Pressing the takeoff config key simulates the application of takeoff power. If the aircraft is not in a takeoff configuration, for example, flaps not in the correct configuration, then an ECAM warning or caution will be triggered. The system also checks the side sticks and the flight control computers for faults. Provided ECAM detects that the aircraft is in a normal configuration, then the takeoff configuration memo changes to normal. Observe that there are no blue action lines on the EWD. We are now at the threshold about to take off. When the engines are set to take off thrust, the ECAM engine page is automatically called. On the engine warning display, notice that the takeoff memo is replaced by normal memos. A magenta takeoff inhibit message has appeared. The takeoff inhibit message is advising you that some warnings and cautions have been inhibited during the takeoff phase. The aircraft is now airborne. After passing 1,500 feet AGL, or 2 minutes after liftoff, the takeoff inhibit ceases and the memo is removed. When the flaps are fully retracted, the ECAM engine page is automatically replaced by the cruise page. When established in cruise, the system pages are periodically reviewed. Call the ECAM engine page. Notice that while the engine page is displayed, the corresponding light on the ECAM control panel engine push button is illuminated. You will study the indications on the system pages in the appropriate modules. So let's continue with the review. Call the ECAM bleed page. The ECAM pressure page. The ECAM electric page. The ECAM hydraulic page. The ECAM fuel page. The ECAM APU page. Notice that there are amber indications on the APU page. Because the APU is shut down, these are acceptable for this stage of flight. Call the ECAM conditioning page. The ECAM door oxy page. The ECAM wheel page. The ECAM flight control page. After reviewing the flight control page, the cruise page can be recalled. Notice that there is no push button to select the cruise page. You have to deselect the manually selected page. Recall the ECAM cruise page. The cruise page is displayed and the ECP has no lights illuminated. As an alternative to selecting the individual system keys, the All key can be used to sequence through the system pages. You will do this in the ECAM Abnormal Operation module. We will now establish a descent for landing at our destination. As part of the approach checks, the status page is checked. Since there is no status reminder on the EWD, the status page is normal. The aircraft is lined up on final approach. As the landing gear is extended, the ECAM system will automatically display the wheel page. The wheel page is displayed to provide information useful for the landing, for example, brake temperatures and spoiler deployment. On passing 1,500 feet with the gear down, a landing memo appears on the engine warning display. On modified A320s and on all A319s, the landing memo appears at 2,000 feet. Note the blue action item reminding you to arm the spoilers. We will arm them for you. The blue action line is replaced by a green action completed indication. Notice that there are now no blue action lines outstanding. At approximately 800 feet, the landing inhibit becomes active, and this is indicated by a magenta memo. The landing inhibit message is advising you that the vast majority of warnings and cautions have been inhibited during the landing phase. At engine shutdown, the ECAM door oxy page is automatically recalled so that you can check slide disarming. Notice the pulsing status message on the EWD. This is telling you that there is a maintenance-related message on the status page that you have not seen. Call the status page. there is a white maintenance status message at the bottom of the status page. This message is an indication for maintenance personnel that a system requires a maintenance procedure at the next program servicing. It does not mean that the aircraft is unserviceable. Clear the status page. The two identical flight warning computers, FWCs, receive data from the aircraft system sensors to generate red warnings, the system data acquisition concentrators to generate amber cautions. The flight warning computers then supply the DMC for the display of alert messages. The attention getters. The loudspeakers for oral alerts and synthetic voice messages.
Speed, speed, speed.
To begin, we will look at what happens when one or both flight warning computers fail. For a single FWC fault, a caution message will be displayed on the EWD. Notice that there are no blue action lines, so no crew action is required. No system page is called, because there is no system page for EIS. Clear the flight warning system. On the status page, you will notice that the aircraft's autoflight capability is downgraded to Cat 3 single. The inoperative systems are Cat 3 and FWC 1. After a review of the status page by both pilots, the ECAM procedure can be completed. Clear status. The cruise page is displayed on the lower ECAM screen, and the ECAM control panel has no lights on it. A boxed status reminder appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for an FWC-1 fault. ECAM complete, screens normal. As a result of the failure, if any other warning or caution is generated that would light an indicator, you will notice that only half of the lights are illuminated. In this example, with the Flight Warning Computer 1 fault, only the lower part of the captain's indicators and the upper part of the first officer's indicators are illuminated. Note, if FWC-2 had failed, the lights would be reversed. The loss of both flight warning computers will remove the automatic monitoring of the aircraft systems. A message and information generated by a DMC is displayed at the bottom of the EWD. There will be no further ECAM cautions or warnings, oral warnings, master caution, or master warning lights. The action lines advise the pilots to monitor the ECAM system pages and the overhead panel for local warnings. Notice that there is a Not Avail list on the right-hand side. The Not Avail items are ECAM warnings, altitude alerts, the status page, automatic callouts, memos. The overhead panel should be checked for any local warnings. The system pages can be checked for abnormal indications either by individual selection of the pages or by using the All push button to sequence through the pages. We will hold down the All push button to show you what happens. Note, if the All push button is released partway through the sequence, the cruise page is displayed. To finish this module, we will briefly look at the use of the emergency cancel push button. It is normally used to cancel an intermittent nuisance message. It may be used, if necessary, to cancel most oral warnings. Let's look at an example of an intermittent nuisance message. When an intermittent caution occurs, the normal oral and visual alerts will be triggered. The emergency cancel push button can be used to tell ECAM to suppress the caution. As a result of pressing the emergency cancel push button, a white message appears on the EWD advising you that the caution has been canceled. After a short delay, the canceled caution message automatically disappears and is transferred to the status page. A status reminder appears on the EWD informing you that there is something on the status page. Select the status page. The status page is displayed, which now has a white canceled caution message. After review, the status page can be cleared. Clear the status page. The cruise page returns on the lower ECAM display, and there is a status reminder on the engine warning display. For the rest of the flight, you will not be alerted each time the ECAM system detects a fault with ILS-1. Now, let's see how you can recall the canceled caution. Press the Recall push button. If you press and hold the Recall push button for more than 3 seconds, the suppression function is removed. The original caution will reappear if the fault is detected.